So we're looking at the first part of this algebra review from Algebra 1. A lot of this material should seem familiar, like something you've done before. A lot of this should seem easy. Some of it I might skip, and some of it might just be a quick explanation. Of course, if you have any questions while we're working through any of the material in this course, of course, you can email me. You can ask a question in class. That's also really good. So let's keep a note on that. So if it's an issue with a question or you need a little bit more detail for something on here, my email is seen here. And of course, you can always ask a question in class. Since most of our class time is going to be spent working on this material, a lot of time will be devoted just for asking questions. Of course, the videos might not always show the detail, but I'm more than willing to help you out if you get stuck. So it starts off first with pattern recognition. With this first set of numbers here, we're going from -5 to -1, 3 to 7. So a good rule of thumb in algebra is just to kind of notice patterns as far as numbers changing. So this is going from -5 to -1. So it's as if they're adding 4. And we see that that continues as it moves from -1 to 3, 3 to 7. And we're being asked to give 3 more numbers in the pattern, so we can assume that this is going to be a linear change, meaning that this is going to be consistent for quite some time. Linear should sound familiar from when you were graphing previously. So if we take this further, just adding on 4, 7 and 4 would get us 11, 11 and 4 would get us 15, 4 and 15 would get us 19. With 2, this is a little bit trickier. We start at 64 going down to 32. So this is a change in 32. Change from 32 to 16, so then subtracting 16. And then also going from 16 to 8, so down 8. So you might notice a pattern with these changes here. So this isn't quite linear. But if we were to take this further, what do you think the change is going to be? What rule is going on here? So hopefully you notice that they're taking half of the previous number. Starting from 64, half of that is 32. Half of 32 is 16. So if we continue this pattern, taking half of the previous number, half of 8 is going to be 4, so we're deducting 4. Getting us 4. If we deduct half of 4, subtracting 2, we continue to take half of 2, that's just 1. So we see that this is a consistent pattern. I won't ask you too much with the types of properties that we use, but this should sound familiar, what's going on here. Some of these I forget, but I'm pretty sure that this is a commutative property, where it's saying we can rearrange the order of numbers. So this is the commutative property of what operation? Should be saying addition. I'll kind of speed through these. We see we have a 4, and we're adding a -4, getting a 0. This is opposites. So anytime we have some version of a number, we add on the negative version of it, those cancel. We have a number outside parentheses, which is then distributed in. So this is using the distributive property. This one comes back a ton. So if there's one to take away, it's definitely distribution. They're all important, but this one in particular is really crucial. Distributing 2 to 8 entity. Down here, what do you think this is? We have 2 fractions. We see that we have 7/8, and we're multiplying with 8/7. What do you think the property is here? Hopefully you're thinking of an R term. It starts with an R. If you're thinking reciprocal, that's a good one. where this is saying if we multiply a fraction with its reciprocal, the product of the two should be 1. This comes back again when we're graphing lines that run perpendicular. So that's nothing too crazy. Again, be familiar with these. You don't have to know them exactly what the property is, but it wouldn't hurt. I think it shows understanding if you can say what property it is. Here we're plugging in values. I won't spend too much time here. So we're plugging in where a is 3. So we're taking 3 squared, deducting 2 with 3 plus 1 in parentheses. 3 squared is going to be 9. Then we're subtracting 2 with the sum of 3 and 4. Sorry, sum of 3 and 1, so 4. Eventually, 9 minus 8, this equals 1. Final answer. I'll give you a moment for the next one. If you want to pause this and give that a shot, go for it. So you should have been taking 5. Eventually, 2 times 4 is 8. Deducting 1 is 7. Deducting 3, but you're multiplying this with 4 plus 2, so 6. So this is really 35, and you're deducting 18. So this should be equal to 17. Of course, if you have questions on this, I didn't show all the work, but you can feel free to reach out in email or ask in class. For this expression, we have some equation, and I think it's a good rule of thumb anytime you have a word problem to underline what you know, underline potentially what you're unsure of. So if we read this out, we have the expression 15 plus 5x. So we have an equation. That's something to keep in mind. 15 plus 5x, where this is modeling the daily cost in dollars of renting scuba gear. Oh, so very summer oriented. That's cool. We'll draw some seagulls over here. Why not? So we're renting summer gear from the water sports store in the expression where X represents the number of hours the scuba gear is used. What's the cost of renting scuba gear for a day when the gear is used for 3 hours? So X is representing the number of hours. That's crucial that we're using. We're being asked to find what it costs to rent for 3 hours. And we have this equation. This is similar to the previous problem, but we're just being asked to go through this wordy scenario and interpret it. So if you followed through with this and you think of just 15 plus 5 times 3, we eventually get 30. But what does the 30 represent? Do we have 30 cheeseburgers, hamburgers, hot dogs, coconut water, nights playing Fortnite? What does the 30 represent in this context? So what units? So you should be saying $30 because that's what we're trying to find. So $30. Shouldn't be too bad. Moving to solving equations, we have 2r plus 2 equals 3r minus 5. So we're working with the variable of r, trying to isolate r. That's crucial. We have 2 sides of this equation to keep in mind. So I think it's going to make the most sense to move 2r to the right-hand side so that we keep a positive coefficient. So that's a goal here, is to keep a positive coefficient. I think it just makes your life easier. I prefer working with positive coefficients, so that's something to keep in mind. Also keeping in mind opposites. So although we see 2r and it's positive, we want to deduct 2r from both sides. Then think, how could we move this negative 5 to the other side? If we're thinking opposites, opposites attract. If you add 5 to both sides, eventually you have 2 plus 5 equals 7. 3r minus 2r gets you r, so r is equal to 7. For some of the other problems, we'll check our work along the way, but for this one, I'm pretty confident it's going to work. for a problem like 8, you have two ways you can solve this one, and I'll actually show both of them. So this has 8 with parentheses of t plus 1, and this equals 64. You might be thinking to distribute, which is totally fair game, and that's something you can totally do. Again, I'm showing two ways you can solve this problem. If you're really crafty, you should know that both of these work, but if you're not convinced, we'll try it. So let's say that for this, I'm going to use the distributive property, which is totally fair game because I have 8 outside parentheses. So if I distribute, or rewrite this, I have 8, t plus 1 equals 64. If I distribute here, I have 8t plus 8 equals 64. Using problem-solving strategy, if we deduct, and I'll actually write our strategy here. So this is what I use if I'm solving equations. So I can either subtract or add depending on what I'm trying to isolate. So here, I'm trying to get rid of this positive 8, so let's deduct that. Leaving 8t equals 56. So we use subtraction because we wanted to think of opposites. We did not use addition. So now we're deciding if we want to multiply or divide. Well, 8's multiplying with t, so we want to divide both sides by 8. We divide both sides by 8, t is going to be equal to 7. Another approach you could have used is that 8 is on the outside of parentheses. So if you just divided both sides by 8, what are you left with on the left side if the 8's cancel? So you should be saying t plus 1 equals 64 over 8, which is just 8, solving for t by deducting 1. T equals 7. So as you see here, two different ways to solve the same problem. If you were really smart, you could just guess and check, because you know it's taking 8 times some number to get 64. 64 is a perfect square, so you know that if 8's already a factor, this is going to have to be 8. It's another approach you could have taken. And this was used as dividing 8 as a factor, which is fair game only if it's factored completely, meaning there's a term outside the parentheses on the one side.